Alright, welcome back to the class. Today we will talk about classification of sedimentary rocks. Once again, just for a review, what is sedimentary rock? Uh, so sedimentary rocks that are formed due after lithification of sediments. Rocks that are formed after lithification. So lithification has two terms combined together, which is compaction plus cementation. After lithification of sediments. Okay, so that is sedimentary rocks. And how do we classify sedimentary rocks? So there are two major criteria on which we can classify based on size of sediments, and another one is based on nature of origin. So based on the size of sediments, there are multiple different types. So this is from your lecture slide. Sedimentary rocks are classified in two groups. One is detrital sedimentary rocks, another one is chemical and biochemical sedimentary formed from ions carried in solution. So detrital sedimentary rock, it's a physical process where sediments of different size, they combine together and they lithify, they undergo compaction and cementation, and they become a sedimentary rock. On the other hand, chemical and biochemical sedimentary rocks are the rocks that are formed due to a series of chemical reactions. So there's a difference. Detrital sediments due to physical accumulation, and chemical and biochemical sedimentary formed due to chemical and biological processes that eventually turn these sediments into sedimentary rocks. So there's a slight difference. So remember that physical processes and chemical processes that make the difference between detrital and chemical and biochemical sedimentary rocks. Here is okay, detrital sedimentary rock. These contain a wide variety of minerals and rock fragments. Clay and quartz are most common. Clay is most common because it is leftover or residue from the feldspar mineral, right? So feldspar is the most common mineral in our in our earth crust, and after going through weathering process, the feldspar turn into clay minerals. And quartz are also another very common sediment that you will find, and it's because quartz are just pure silica, and it's a very stable compound. That's why it is very difficult for weathering agents to break it down. So quartz are also another compound which is very commonly found as sediment. So clay and quartz are the most common minerals that you find in the sediments, and these sediments will eventually form the sedimentary rock after going through the process of lithification, which is compaction and cementation. Distinguished by particle size, so you can classify this detrital sedimentary rock based on their size. So this is a figure from your textbook which classify the sedimentary rocks based on their size. So there are four different categories based on the size. Coarse are the sedimentary rocks are called coarse sedimentary rock when the pieces or the constituent sediments are larger in size, so over 2 millimeters in diameter. The average sediments that you will find in this rock are over 2 millimeters in diameter, and there are two different types: conglomerate and breccia. So conglomerate are those where the particles or the constituent sediments are over 2 millimeters in size, but those are more like rounded and they have a smooth surface, whereas breccia is one which has angular and sharp edges. So that is one difference. They both have sediments of about the same size, over 2 millimeters, but one is rounded and smooth on the surface, whereas the other one is angular and sharp. So breccia is angular and sharp. So that tells a lot about the the environment in which these sediments were formed. So I will just quickly go over this. So environment play a major role. The size of, sorry. So environment play a major role. Environment plays a major role in the shape. It controls shape, size, and roughness of sediments. And how that happens. So now let's try to understand that. So remember, there are these natural weathering agents. Right? So make sure you remember this. This will be in your exam. Natural weathering agents, and those are wind, rain, waves, glaciers. Wind, rain, waves, glaciers. These are our major natural weathering agents that cause weathering of the sediment. So what happens is these sediments, so think about a riverbed. So this is your river. Just trying to draw it here. So what happens, this river is carrying all these sediments, right? So some are sharp, some are small, some are large in size, some are medium in size. So it is carrying all these sediments, and what happens over the time, these sediments are colliding with each other, right? So they are in group and they are carried with the natural water stream, and as they are being carried, they are colliding with each other. So what happens over the time, all of these sharp edges will start to smoothen up over the time. So longer these sediments stay in this stream, smoother it will get over the time. And then another important thing that will happen over the time, during this course of collision, they will start to break into smaller sediments. So that tells a lot about the environment in which these sediments were formed. So the river sediments, or the sediments carried by wind, they both will go through the same kind of collision mechanism over the time as they are carried from one location to another. So they will start to get smooth and they will get more rounded. Their sharpness or sharp edges will start to disappear over the time. So that is how you can tell about the environment in which these sediments were formed over the time and how long these were carried. So longer they were carried, smaller those sediments will become, because they will continue to collide and they will continue to break into smaller and smaller pieces. As the pieces will get smaller, they will again be sharper and become rough. So now the agents will again break them down and they will become smoother over the time. So, and another important factor that I want you guys to understand is the size of the sediments and how they are deposited. So imagine as the river is flowing, it has certain energy to carry these sediments. So as the river gets weaker in its flow stream, it will starts to drop the heavier sediments first. So as the river is flowing faster, it will be able to carry the heavier sediments, but as it starts to slow down, it does not have enough energy to carry the heavier sediments. So the heavier sediments will starts to drop out from the water column first, and then the medium size, and then the smaller size, and finally the fine size sediments will drop out from the river stream. Or the same thing with the wind. When the wind is carrying, as the wind starts to slow down, it will drop the heavier sediments first and then the lighter ones. So that is called as natural sorting. Natural sorting, where sediments are sorted based on size during erosion. So erosion is that process where the sediments are carried from one distance to another. So the process of sediment erosion is a combined process. Both transportation and weathering is happening. So this erosion is a combined term used for weathering and transportation. So natural sorting is one event that will happen during the process of erosion, and then another process that will happen is the smoothing of the sediments, and the sediments also break down to become smaller in size as they stay longer with this natural weathering agent. So that is why we have all these different sizes of sediments in the sedimentary rock, and those size of the sediments, the smoothness, the texture of the sediments will tell you the environment in which these sediments were formed. The next category is medium, where the size of the sediments become much smaller, 1 over 16 millimeters to 2 millimeters in size. One is sandstone. As the name indicates, it will have sand size particle, very fine in size. The another one is called arkose. This also has sand particles, but it has over 25% of the minerals are feldspar minerals. So remember that feldspar is the most commonly occurring mineral on our earth crust. So just remember that fact as well. It may be in your exam. Fine is the third category, where this sediments will become even smaller in size, so 1 over 16 to 1 over 256 millimeters in size. So these are even finer sediments called siltstone. So this will have majority of those are very fine silt size sediments, and some of them might be a larger size sediments. And the next category is very fine. It is less than 100 256 millimeter in size. So those are clay minerals, really fine, finer than the sand particles, and they make the shale or mudstone. Those are the examples. So on this column you have these different example of sedimentary rock based upon their sizes: coarse, medium, fine, and very fine. So I want you guys to remember the difference between conglomerate and breccia. What is the main difference? Conglomerate is rounded sediments, breccia is angular and sharp sediments. Okay, so let's look at this another figure from your textbook. So this one is figure 2.21 in your textbook. So this shows another form of classification based on the origin, how these sediments were originally formed. So just we saw that the physical processes by which the chemicals they combine together and make this sedimentary rock. Another one we talked about the chemical and biological processes that can make these sediments. And another way to classify them is based on composition, whether they are carbonate in nature, silicate, sulfate, halite, or altered plant fragments. So this classification is based on composition. So here you can see calcite is one example. Calcium carbonate is also one of the most common sedimentary rock on our planet Earth. And this again, based on the size of the sediment, you can further classify them from fine to very fine, and then fine to coarse. And then there are these other types of calcite which are formed from biochemical activity. So these first three in this group are formed from physical processes, or those are called as detrital sedimentary rocks. About 90% of the calcite are formed by biochemical processes. So calcite are also, you will see it as the shell of this microorganism. So once again, the nature of these sediments will tell you a lot about the environment in which these sediments were formed, and that is how you are going to discover the history of our planet Earth, how different places were covered under ocean by finding these different sediments. Those discovery of these marine based sediments will tell you there used to be an ocean in this location which seems dry and open land at the current time, but if you discover these sediments, especially these marine based sediments, then that will tell you that in the past at some time, and then you can carbon date these sediments, and that will tell you how old these sediments are, and then you can make this determination that how old in time, how many years back in time there used to be an ocean here, and that is where all this marine deposition of biochemical shell occurred in. So one example is coquina. This is visible shells and shell fragments loosely cemented. So these are not very lithified sediments. You can easily break. If you find it, if you rub it in your hand, then you will find that lots of these sediments are falling off from this rock. So these are loosely cemented fragments, and these are formed by the shell. These microorganisms, marine microorganisms, they wear on their body. Another one is fossiliferous limestone. So limestone that has some fossils buried inside it. So once again, these fossils will give you an idea about the environment in which this rock was formed, and tell you about the history of that area in which this rock was formed, whether it was a swamp, whether it was a dry land, or whether it was an ocean, or it was a tropical island, you can say, depending on what type of sediment you will find buried in this rock. Another category of biochemical calcite is chalk. This is also formed from a very small microorganism, and here is a figure that I want to show you. Okay, here it is. So this is a chalk plateau or chalk land or chalk cliff. It is somewhere in England, I think. So you can see these microorganisms, planktons called coccolithophores, and these are smaller than the size of eye in the needle. So that can give you an idea about the scale, that how these microorganisms, the shell from these microorganisms end up making this giant landscape called chalk cliff. So this is where I want you guys to appreciate this diversity of scale that we observe in the study of earth science or in the study of geology, something that we discussed in the introductory topic, that how this diversity of scale, going from microscopic scale, then going to hundreds and thousands of meters of scale, and this process of cementation and compaction occurred over hundreds and thousands of years. So these microorganisms, when they die, their shell will drop in the ocean water and they will settle on the bottom of the ocean bed, and they end up making this sedimentary layers. And as more and more animals will die, those their fossils